a third of the world is unconnected, and that means completely off the grid in terms of being connected to internet. Number two is emergency communication systems are quite important. So especially with places like Artsakhi and with war and many displaced Armenians, as well as in the Palestinian conflict happening at the Gaza Strip. And number three are grids. Specifically, telecom systems require a lot of infrastructure that are overloading our grids. So before I start, none of what I'm saying here is investment advice or anything like that. I'm not trying to sell you guys anything. I just want to bring awareness to a lot of the technologies that we're trying to build. So there are three key problems in terms of the data. So in terms of being reliable, the American Society of Civil Engineers gave our grid a D+ rating, which is terrible. According to broadband source, as noted, a third of the entire world has access to no internet as of 2023. And the key holders of the internet is a select group of people, and most of the internet is severely centralized. And the actual size of the market that we're trying to solve is there's a $3.8 trillion telecom industry in terms of what the size may reach by 2026. And the smart infrastructure market by the year 2028 might reach a $413.16 billion market size. So Stark Drones is trying to build a lot of technologies to try disrupting that, and we're trying to build technologies centered around heavily disrupting telecom and infrastructure as industries. So we have a lot of intellectual property. We've been doing R&D for many years to solve these problems, and I will go over some of the core technologies now that Stark Drones is trying to build. So I'm starting with one that doesn't affect infrastructure as much, but we're building things ranging from underwater internet systems to internet balloons and actual full CubeSat deployments and our own compute module that also works as a gateway. So the underwater wireless network is primarily centered around actually trying to convert sonar signals underwater. Convert signals underwater using sonar, because a problem with signal distortion is when you have wireless signals, there's something called wave-based propagation, which means the signals underwater get distorted because there are opportunities for the signals to bounce more often. That's why when you deploy CubeSats or satellites, you deploy them really high up in the sky because there's less room for signal distortion. So when we wanted to do underwater wireless networks, it's not centered around like high bandwidth, high connectivity, but more centered around connecting to real-time networks and sensors to actually get facts about our ocean. And we use sonar conversion and different methods in order to actually build a telemetry network underwater. So there are multiple variations of the prototype. The first variation is obviously the most crude compared to the fourth generation. So there has been a lot of R&D work in terms of actually making it presentable and more usable as a technology. And one of the main goals of underwater wireless networks is when you have toxin detection or you're trying to detect harmful cyanobacteria, the current method is to use chemist or biochemist to actually get data and collect a wet or dry chemical sample. Right now that takes 24 to 48 hours and it's extremely costly. You're talking about like sometimes up to $40,000 or more on taxpayer dollars just to quickly collect data and then test it in a lab. We're trying to build a real-time sensory network that's able to get that information immediately. And this will help with a sustainable future. Obviously, if you're able to get data about the harmful toxins that affect our ocean, harmful algae blooms, phosphorus run-ons in real time, it will help actually bring that data to scientists much quicker and be able to be utilized for targeting different places in the ocean for like underwater carbon capturing or targeting mineral offloading or fixing lots of those algae blooms and phosphorus run-ons. And you're saving a lot of ocean lives. You're also potentially even saving people's life because harmful cyanobacteria, especially in heavily polluted lakes and oceans, those places that have really bad cyanobacteria could actually have flesh-eating viruses, and maybe even potentially make people who swim there paralyzed. So obviously, cleaning the ocean is extremely, extremely efficient. And also, obviously, exploring the ocean. And we want this underwater network to be modular. We want it to be easy to expand and connect with our other networking devices. And now we want to talk about CubeSats and nanosatellites because that is the technology that actually affects people the most, especially in terms of cities. So Stark Drones is working on cube satellites, and cube satellites are these really small miniaturized satellites that are 5 inches by 5 inches by 5 inches, sometimes on average. And we want to compress network packets for starters, and we also want to work on different fuzzy logic algorithms in order to make CubeSats more efficient for providing WLAN, LAN, LoRaWAN, and radiosonic communications in terms of like actually beaming them to gateways. And that will actually cost a really cheap deployment method compared to what's out there. And eventually you're actually going to use aerostat balloons as a launch mechanism. You could also obviously piggyback these CubeSats off of ride-shares like potentially SpaceX's ride-share program and others, but you wouldn't need to. You could eventually use aerostat balloons, which are these balloons that could hold helium and hydrogen for long periods of time, and actually use that to deploy the CubeSats. And that would actually be a net carbon neutral or carbon free emissions deployment method just from balloons. And this goes beyond telemetry because we're potentially able to offer connectivity to different countries, especially third world countries, at a much cheaper rate. And interesting fact is, in terms of those who don't have access to the internet, there's obviously going to be a literacy problem. So regardless of your like religious beliefs, right? What is one of the most popular books in bibliography, right? It's probably the Bible. And a third of the world never even heard the Bible, which is like one of the most basic books of literature. So that means like a third of the world probably doesn't have access to better physics books or math books. And you look at the GDP of some of these countries, and it's literally in the billions compared to like tens of trillions of dollars in first world and even tier 2 countries. So huge literacy problem that could be fixed with connectivity being one of the first steps. And not only would the deployment of CubeSats help with the literacy problem, it would help make people more connected, but eventually being able to have these CubeSats would allow for space exploration to be more accessible to the general public. And you could get a whole lot of data in the future because of that. And obviously we want to build a grid. We want these to have swarm capabilities, so we want them to be modularly built. And we want to eventually not just utilize this for low Earth orbit, but potentially utilize these CubeSats to be deployed in interplanetary missions in the future and be able to get all sorts of data if funding allows. So, as noted, it's extremely modular, and we aim to work with various communication standards. A huge step in that is once we're able to get more and more data in the future, we're able to potentially work around FCC regulations and be FCC compliant for a lot of our devices, and maybe even get approved as an ISP or internet service provider. And sorry, this takes a while to load because of the internet, but one of the ways that we want to deploy these CubeSats obviously would be internet balloon systems. So an example of a system would be like Google's Project Loon, for example, was an attempt at internet balloon telemetry. We believe because of our algorithms and the size of our CubeSats, we're able to potentially do this at a more portable and sustainable way that would actually be able to eventually target a lot of cities. We tried doing a telemetry test launch in Harbor Beach, Michigan, and we're hoping to hopefully be able to do more test launches in the future. And we want the internet balloon systems to be put in place so that we're able to collect data, make people more connected, as you already know, and eventually the potential price per launch, and that's allowing for room for profit margin to have like telemetry in terms of having an entire like small to mid-sized city even connected could be potentially 17K per CubeSat launch and internet balloon system, and that's probably a tethered, like maybe 5,000 foot launch. But 17K for internet balloon system, that's in comparison to potential 350K plus per satellite deployments. And even Amazon's Project Kepler is over $2.8 million. And potentially it's only like twice the amount of speed. So there's a lot of obvious market opportunities that this could potentially provide in the near future. And as said, this is to connect the unconnected. So the cheaper the cost, especially if you're talking about prices that could potentially be a 20th of the cost and whatnot, that will really help a lot of those countries. And we're trying to target beyond just third world countries. And this brings me to my next slide, which is protecting our sovereignty. So protecting our sovereignty is a very interesting thing because it goes beyond just the potential of spyware satellites and trying to bring those down, but also goes to warfare. So something not commonly known is when there's a missile strike, for example, and another country wants to bring down a missile, they're using ballistics to bring down that missile most of the time. And that causes more civilian devastation and civilian lives. Something we potentially want to do in the future is have CubeSats that are able to intercept signals for missiles and bring them down without the use of ballistics. And that could potentially minimize the loss of civilian lives if that opportunity arises. And another big thing is we want to be more data oriented. So we're trying our best to get as much data as possible and work in breakthroughs for communication over time. And this brings me to the compute modules pitch deck, which I do have an example prototype of the compute module. So Stark Drones is working on signal compute modules that can be used for both novel research or commercial purposes. So our compute modules could potentially act as gateways for a lot of these devices. I will probably be showing this device after my talk, but it has a built-in MCU, it has a LoRaWAN chipset, and it has different modular chipsets for communications. And it could actually work where you could program the MCU and you could be able to connect and pair with LoRaWAN or the modular chipsets on those boards and act as gateways for a lot of these CubeSats and IoT devices. And this would help in terms of it actually being built for horizontal scaling. And our why is not just for the research and trying to develop this high-level form of computing paradigms and communications, but obviously we want to target the engineering market, we want to target the non-civilian and military market potentially, we want to target the potential for third world aid, and we also want to eventually make this open to the hobbyist market, which would be a very important thing in terms of also the mission statement of potentially making space more accessible. And that leads to my talk on like, it's built for experimentation. You could even utilize a lot of these same sort of telephonic systems for avionics and things of that nature, modularly built as noted, and eventually with a lot of these, there's protocols that could be in place where you could eventually have open peer-to-peer peering or utilize a lot of these devices for distributed networking. But most importantly, you could utilize these devices for making the world a more connected place. And that's the main goal that Stark Drones wants to do. Thank you.